Hello everyone, our next topic is source transformation. Here when we are talking about the source transformation, we have two kind of sources, that is voltage source and the current source. So alternatively, to make the analysis easy in our electrical circuits, generally we do the source transformations, that is from current source to voltage source and vice versa as well. Let us proceed with the current source to voltage source transformation. How we can do that? Generally, a current source is represented by a resistance in parallel with the current source, whereas voltage source is represented by the series connected resistance with the voltage source. It implies the internal resistance of the voltage source is connected in series, whereas the internal resistance of the current source is connected in parallel with the current source. So, current source connected in parallel with the internal resistance can be converted to the voltage source by connection of the resistance in series with the voltage source, and the magnitude of voltage source will be the product of current and this particular shunt resistance, that is V equals to IR, and the magnitude of resistance in connected in series will be equals to the value of shunt resistance of the current source. Vice versa, and as we have studied the source transformation from current source to voltage source can also be transformed to the current source. For this particular transformation, we can use the series resistance connected in the voltage source will be connected in parallel with the current source, and the magnitude of current source will be coming out to be as the voltage divided by the current. A voltage source connected in series with the resistance can be converted into the current source. The current source magnitude will be coming out to be as the voltage divided by the resistance. This resistance value is same as the internal voltage resistance, internal voltage source resistance, that is RSE, whereas the magnitude of shunt resistance will be directly equals to the series connected resistance in the voltage source. In this particular manner, we can convert the voltage source to the current source and vice versa, that is current source to the voltage source. Continuing with the source transformation numerical problems, let us discuss a problem based upon the concept that we have studied. You have to convert a voltage source of 24 volts having a series internal resistance of 2 ohms. Now, you have to identify the equivalent current source. So, how you would be calculating the value of current source and the value of resistance? Directly the value of shunt resistance, that is REXT, will be equals to the value of series resistance, that is 2 ohms, and the value of current source will be equals to voltage divided by the value of resistance, that is coming out to be as 12 amperes. So, in this particular manner we can easily transform the sources in our electrical circuits. The basic application of source transformation is making the circuit analysis easy which are complex in nature, so that we will be able to identify and calculate the required electrical quantities in the circuit analysis part. With this, the DC circuit analysis part is completed. So, in this particular session, we have completed the Kirchhoff's laws and the source transformation. I hope you have understood these particular topics. In case of query, you can please contact me on my email ID preti@svsu.ac.in. Thank you very much.